So the first two videos on lesson 1-3 were focused on the first 5 problems on these instructor-led problems on page 35. Notice that what they all have in common, whether we came out with a unique solution, um, like m equals a number, t equals 4/3, or we came out with the no solution example or the all real numbers example, is that we were dealing with whole numbers primarily, at least up until the final solution, right? The final solution to the problem here. So in this case, we had t equals 4/3 as the final solution. Here we ended up with no solution. Here we ended up with all real numbers. So until I came up with to that final step, I was dealing with whole numbers. Well, in the next part of the instructor-led problems, you can see we deal with decimals and fractions, okay? Now, this, again, instructor-led problems, this is page 36 of the book. As far as decimals go, in this class, I just treat these just like I did whole numbers. Most people don't have a problem dealing with decimals, especially if they're not decimals that are repeating decimals or anything like that. So most people deal with decimals as exactly the way they dealt with whole numbers. So for instance, let's take a look at this example, question 6 here. 0.4 or 0.4 minus 0.3y equals 2.5. Well, what we're going to do is we're going to notice that we have a constant term of 0.4. We have a term with a variable that's minus 0.3y, and we have equal to 2.5. So what I would do, just like we did before, is I would take and notice that first off, the left-hand side and the right-hand side are as simplified as I can get it. So the next step would be to get rid of the constants on one side, get rid of the variables on the other. The quick way to do that is to subtract 0.4 from both sides. And we got one more there. If I do that, I end up with a negative 0.3y is equal to 2.1. Now my coefficient of y is negative 0.3. That is not going to change anything. We're just going to divide by a negative 0.3. Whoops, hit the wrong button there. Let me do this a little bit better. There we go. Make it look a little bit nicer. So we're going to divide both sides by negative 0.3. Now, dividing the left-hand side by negative 0.3 gets rid of the negative 0.3 coefficient of the y. That's going to end up, or I should say, you're going to end up with just a y on the left-hand side. If I take 2.1 divided by negative 0.3, I get a negative 7. And so notice that the techniques of solving this equation did not differ at all from what we did before. So with decimals, especially decimals that end, we don't actually change our techniques. We simplify both sides of the equation. We get our terms with variables on one side, constant terms on the other, and then we divide by the coefficient in front of our remaining variable. So there you go. Now that works no matter what the decimals are, no matter if we have distributive properties or not. So if we have if we need to utilize distributive properties, we're just going to do those with decimals. 0.35 times in parentheses x plus 6 in parentheses is equal to 0.45 times in parentheses x plus 7 in those parentheses. So we're just going to distribute that 0.35 times x plus, and we're just typing this I'm just typing this in on my calculator. 0.35 times a positive 6 is a positive 2.1. 0.45 times x is 0.45x plus, well, 0.45 times 7 is 3.15. Again, that's just calculator work. Nothing interesting there. Now, what we're going to do, same as always, get rid of some terms with variables on one side, terms with constants to the other. What do we want to do? Well, you can do either way. Since I've been getting so far, I've been getting rid of the terms with the variables. I've been getting rid of those from the right-hand side. Let's do one where I do it the opposite way. Let's get rid of the terms with the variable from the left-hand side. So let's subtract 0.35x from the left-hand side, which forces me to subtract 0.35x from the right-hand side. Okay, we'll end up with a 2.1 is equal to 0.1x plus 3.15. Okay. At this stage, we got to get rid of this 3.15 from the right-hand side. So subtract 3.15 from the right-hand side. If I do that, I need to subtract from the left-hand side as well. Take me a minute to write that down, but you see where that goes. If you do the calculations and just type this in, 2.1 minus 3.15, you get a negative 1.05 is equal to 0.1x. And the usual thing happens here. We have all of our terms with a variable on one side, all of our terms without a variable combined on the other side. So I just need to divide both sides by the coefficient of x. So what do? I take that negative 1.05, divide it by 0.1, set that equal to 0.1x divided by 0.1. Oops. And there you go. So negative 10.5 is equal to x. By the way, just as a side note, if you would have subtracted the other way, if you'd have subtracted 0.45x and from both sides up here, and then you would have subtracted 2.1 from both sides, you would have ended up with the exact same solution. You would have ended up, it would have said x equals negative 10.5. So you just swap the sides, but it would have said x equals negative 10.5. Okay. So there you go. So with decimals, we treat them just like we treat whole numbers. Okay, that's how I tend to do it. Now with fractions, fractions are a little bit more complicated. We can, if you feel comfortable enough, treat these just like whole numbers. So here, for instance, we have 3/4 W equals negative 9 divided by 20. So if I wanted to say, well, there's no like term, there's no simplifying each side. All of the terms with a variable on their left side are on the left side. All of the terms which are constant are on the right-hand side. So we're at our very last step. If I want to treat this like whole numbers, I can. I would just have to divide both sides by 3/4. I'd have to be really careful about how I put that into my calculator because we know order of operations is especially delicate when we're dealing with fractions. But you could have easily said, well, let's divide the left-hand side by 3/4. Let's take the right-hand side, -9/20, and divide that by 3/4, and let your calculator do the work. So that is one way. You can just treat these as numbers. That's fine. But what I like to do is I like to do something called clearing fractions. And this is going to help us not just in this example, but also in our next two examples that we're dealing with. So we're going to clear fractions. Now, by clearing fractions, this is basically just a simplification step. So this clearing fractions, think of it as simplification. All right, so it's in that simplification step. So here's how we clear fractions. We need to multiply both sides of this equation by a certain number. And by multiplying by that certain number, all of our fractions are going to magically clear out. All right, and we're going to be left with whole numbers. Now, in this case, and in every case, there's a lot of numbers you can choose. But the number that I'm going to clear fractions with is sort of a brute force clearing fractions. Brute force clear. All right. There's much more sophisticated ways to do this, and that you may have encountered before that utilizes least common denominators. You may have heard the least common denominator. Um, that's sort of the most sophisticated way to clear fractions. I'm going to do sort of one of the least sophisticated ways. I'm going to just go brute force clearing of fractions. Now here's what we do. We look at our denominators, which are 4 and 20. So our denominators are 4 denominators. Whoops, spelled that wrong. Are 4 and 20. So all I'm going to do is I'm going to take 4 and multiply it by 20 and come out with an 80. Now this will always work. I don't want to think brute force clearing. So brute force clearing is always just taking all of the denominators that I see and multiplying them together. Now again, like I said, there are other methods you can utilize, but this one will always work. It's really easy to do. And it doesn't actually leave us a whole lot of room to screw up the least common denominator. By the way, the least common denominator here is 20. So you could have multiplied by 20, you could have multiplied by 40, you could have multiplied by, lots of other numbers. But 80 is sort of the brute force clearing. I see all of my denominators, multiply them all together, I get a number. And so what I'm going to end up with is I'm going to end up taking both the left-hand side and the right-hand side of this this equation, and I'm going to take and multiply by 80. So take the left-hand side, multiply by 80. Take the right-hand side, keep hitting the wrong numbers, multiply by 80. And that's the brute force clearing method. Okay? little bit of a tongue twister. So we take 80 times 3/4. 80 times 3/4 on your calculator is 60W. That's the left-hand side. 80 times -9/20 becomes 36. Notice that by multiplying by 80, I got rid of all the fractions lying around, and now I'm dealing with whole numbers. So now I can say, well, 60W equals 36. I know what to do there. I know all I have to do is divide both sides by 60. W is going to be whatever I get when I take 36 divided by 60. 36 divided by 60. If you punch that into your calculator, you get a decimal of 0.6, but is a fraction that is 3/5. Okay, so brute force clearing method says all denominators multiply together, multiply the left-hand side of the equation by the denominator, multiply the right-hand side of the equation by the denominator. All right, let's try another one, or let me show you by an example, via an example, another equation that I can do that with. So let's take the next one. -2/5 p plus 3/2 equals 1/5. So we're going to do brute force clearing. All right, so I look at my denominators. I got a 5, a 2, and a 5. Some people would say, so since we have 5 twice, I don't have to write it. I'm going to say, let's take this brute force clearing and take it literally. So 5 times 2 times 5. You come out with 50. So there we go. So we take our equation and we multiply the left-hand side by 50, and then we multiply the right-hand side by 50. Now on the left-hand side, in this case, we have to distribute 50 times -2/5 p, 50 times 3/2, excuse me, 50 times -2/5. I'm typing this into my calculator. I ended up with, whoops, 20, -20 p plus, when you take 50 times 3/2, you end up with 75. So that's what I get when I distribute the 50 into the left-hand side. The 50 can be multiplied by 1/5. That gives me 10. And there you go. So notice that brute force clearing method. When I did that, it wound up with an equation, one variable, but all whole numbers. So now I do the same thing as I have always done. I'm going to subtract 75 from both the left and the right. I'm not going to write that down. I'm just going to write the next step here. So subtract 75 from here, subtract 75 from here. I get -20p is equal to -65. When I divide both sides by 20, we end up with p equals -65. Whoops, -65. Scroll down a little bit. Over -20. And as a reduced fraction, that is 13/4 as an improper fraction. Again, if you want to write 3 1/4, that's okay too. But there you go. 13 over 4. So that's the idea. That's that brute force clearing method. Now, one little other twist that you could end up with is a twist like this one, 3n plus 5 over 2 equals 4 plus 4n plus 2 over 4, where you see that a fraction has a numerator which has multiple pieces in it. You see that here and here. And then we have other terms that aren't fractions at all, like 4 here. Now, brute force method still works here. We just have to be a little bit clever about how we view this 3n plus 5 quantity all over 2. All right? So let me write the brute force clearing. So brute force clearing, well, the only denominators we have are 2 and 4. So we could take 2 times 4 equals 8. We're going to multiply both sides by 8. Okay? Now, well, I guess I can write that. I'll write that. So we're going to take 8, multiply the left-hand side of the equation, take 8, multiply the right-hand side of the equation. Okay? Now you may ask, well, how do I distribute an 8 times 3n plus 5 over 2? All right? And what we have to realize is that if you remember, multiplication and division were on the same level in lesson 1, 2. So because they were on the same level, it means distribution by multiplication works the same as distribution by division. In other words, I can think of this dividing by 2 as taking this first piece and dividing it by 2, and also this second piece dividing it by 2. So in other words, the left-hand side, what I'm thinking of is 8 times 3 halves n plus 5 halves, like that. So in other words, I can take the 3n, divide it by 2. By the way, that's just 3 halves n. And the 5 and divide that by 2. That's just 5 halves. And so I can see this single fraction, 3n plus 5, all divided by 2, as the same as 3 halves times n plus 5 halves. Now you can do the same thing with the right-hand side too. Be careful, the only thing that 4 is dividing this piece. It's also dividing 2, but this original up here, 4, is not dividing. So, leave that for this original 4 here alone. But plus 4 over 4 n plus 2 over 4 and my parentheses. So if you see it like that, then it's pretty easy to distribute. 8 times 3 halves, 8 times 5 halves, 8 times 4, 8 times 4 over 4, 8 times 2 over 4, right? So let's go ahead and do that. Let's distribute 8 times 3 halves. Let me write that down. 8 times 3 halves. That is a 12. So we're going to end up with 12n plus 8 times 5 halves, I believe is 20. 8 times 4, 32. 8 times 4 over 4 is 8. So you get 8 in there. Plus 8 times 2 fourths is 4. Okay, so you get that. And now we're dealing with whole numbers. Now I've brute force cleared these fractions, And now I'm dealing with an equation just like that I would have seen in the first 3 problems of this lesson. So there we go. What I would do, combine like terms, simplify both sides. So what we would end up with is 8n plus 36 on that right-hand side. I'm going to subtract 8n from both sides. Hopefully we can just do that. That's going to be 4n plus 20 equals 36. Again, that's what I get when I subtract 8n. So we go subtract, oops, yeah, subtract 8n from the left, subtract 8n from both the left hand side and the right hand side of the equation. All right. You're left with 4n plus 20 equals 36. Now subtract 20 from both sides. Subtract 20 from the left, you just get 4n on the left. Subtract 20 on the right, you end up with 16 on the right. Divide both sides by 4. And you end up with n equals 4. So n equals 4 is the final answer. That is the solution to this equation here. All right. So again, clearing fractions, I'm using the brute force method. In other classes, you'll find least common denominators, obviously. You could do that too. But brute force, I tend to think is a little bit quicker. You don't have to think quite as much when you're using the brute force method. So there you go. That's how to utilize clearing fractions and just dealing with decimals in section 1 or lesson 1-3. Obviously, if you want more problems to practice, there's some cooperative group problems that mimic those a few pages down, specifically on page 40 and 41. And then there's some at-home practice problems too. Okay. Our next video will get into applications.